So Euler's method is a method of solving differential equation through numerical approximation. So instead of the tangential approximation where you find one point of f(x) and approximate other values on the slope, Euler's method will make use of the step size h to adjust every single axis, or adjust every single point on the axis and adjust the slope so to get a better accuracy of the equation. And then to derive the formula yn plus 1 equals to yn plus h times f prime xy, first you need to sub in the previous or the initial value of f prime xy into the dy dx to find the gradient, the slope. And then to find the new y value, yn plus 1, you need to take the yn and then add the gradient times the step size, which is this one times this one. Because the gradient m is equals to h times f prime x over h, and then it cancels out to become f prime x. So and when you submit back inside, you'll just be the step size times the gradient, which will be this one, and you will form this one, and you'll get a new y value.
To solve the question using Excel sheet, first you have to have 3 columns, n, x-axis and y-axis. So given initial that x equals to 0 and y equals to 1, you have to find y when x equals to 1. So to find the x with each increment of the step size 0.1, we have to add the previous one and then add it with the step size. And then we can just drag it down so that we can get all the way until 1. X equals to 1. So to find y, we can use the formula using the previous y and then add the step size and multiply with the dy dx x over the y square, this one square. And then you should get the y, and then we will drag it down until 1. So we will get y equals to 1.339315 when we have x equals to 1. To solve this question via general solution, first you have to separate the variables y squared and x, and we integrate both sides, we will get y cubed over 3 equals to x squared over 2 plus c. And given initial condition that x equals to 0 and y equals to 1, we will get c equals to 1/3. And then we want to find y as the subject, so we have to times 3 throughout, and then cube root so that we will get y equals to 3x squared over 2 plus 1, and the whole thing power of 1/3. And then to find y1, which is x equals to 1, so y will be equals to 1.35728808, which is the y exact value. And then from our Excel sheet, we know that y Euler's equals to 1.339315. And to find the absolute error, we have to take y exact minus y Euler's, which we will get 0.017893808, which we round off to 0.01793 as f. And then to find the error rate, you need to take the error, divide by y exact times 100%. So we will get 1.318427, which we round off to 1.32%, which is on 3SF. So the Euler's method is off by value of 0.0179 at y1 with the error rate of 1.32% compared to the exact value of the differential equation which we solved by general solution.